All right, guys. This lesson is really trying to cover why we are required to have no main bonding jumper at a sub-panel. And oftentimes people install panels and they find a green screw in the box, and then they install the green screw, which connects the grounded circuit conductor to the equipment grounding conductor, or the metal box in the frame of the enclosure. And they do it by accident because they really don't know the theoretic danger that is inherent to doing that. So in other words, this picture represents the correct way to wire a sub panel. And it's a very generic picture, but it shows a lot. So what I want to do first is at least focus our attention on this piece of the drawing. I'm going to roll this in here so you can kind of see where I'm going with this. Now, this piece represents, let's just say hypothetically, you have a 200 amp main panel. And in that 200 amp main panel, I've got a bunch of circuit breakers that I didn't draw in, but I've got another breaker that's a 2-pole 100 amp. Let's just say that's the one on the right. And somebody says, I want a sub panel to be put somewhere else. I don't care. It could be anywhere. It could be a detached garage or something like that. And you ran 100 amp cable over to that panel. However you got it there is irrelevant. But the important thing is what you see in this picture is you left with 2 ungrounded circuit conductors, which are our HOTS, 1 grounded conductor, which is, in other words, your neutral, and you also have an equipment grounding conductor inside that sheathed SC cable or whatever, underground service cable, or maybe you've got, you went underground with PVC and then you pulled some, THHW or something. And those wires would then come all the way over to wherever it is that your sub panel is, and in this case, connect into the main circuit breaker in that panel, and you've got a neutral bar and an equipment grounding bar, and then I just threw in a 20 amp circuit to make you understand what could actually happen. So, in the other panel, we're going to notice something different than what's in this panel. So if I kind of zoom in over here, as best I can, I want you to take a look at that the grounded circuit conductor, which is your neutral, is here. And just as an example, it's connected to a neutral bar. Your equipment grounding conductor is isolated. It's not touching your neutral bar. It's got its own equipment grounding bar, and then you have whatever size equipment grounding conductor would be required for a 100 amp service. And you would size that based on your overcurrent device. So you go to look at your overcurrent device. If you wanted 100 amp, you'd go to table 250.122 in your code book. You'd see based on 100 amp, you'd come up with your wire size. In this case, the important thing to notice here is there's no main bonding jumper. There's no connection between your equipment grounding conductor and your grounded circuit conductor. But if we went back over to this panel, you'll notice that the grounded circuit conductor and the equipment grounding conductor, and of course any other equipment grounds, are actually connected to the neutral ground bar. And in that panel, you usually receive a green screw, and that green screw would go through the bus, and then it would screw into the metal busing and then into the back of the panel board can, hence bonding all your equipment grounds and your grounded circuit conductor neutrals all to the same point. Now there's a reason why we do this. The first primary reason is this is the service, and you're only putting in your main bonding jumper at the first form of disconnect of your service when you enter the building. And oftentimes, required by code, is the main service disconnect, if it's in the building, has to be as close as practical to entry of the building. And I've been with inspectors that want it immediately on the other side of the wall, or no more than 10 feet from entry into the building. And oftentimes you'll see that the service is right next to an outside wall somewhere. And there's a theoretic reason to having that put in that place. Let's go back to the other panel, and I'll show you what can happen if you inadvertently connect, because all panels are going to come with that green screw. They're going to come with the green screw. So let's just say I inadvertently, and I'm going to pretend that this is a green screw. I put the green screw and I connect my ground bar or my equipment grounding conductor to my neutral. Now watch what will happen here. So if I put my camera over and I pretend I have a load. So over here, I'm looking at me plugging into a receptacle. So if I plug into a receptacle and all of a sudden I'm looking at it, I'm all plugged in, everything's working. My ground is isolated from my neutral terminal on my circuit breaker, and I plug something in, and let's say something happens to this piece of equipment. Something happens, and I get a ground fault. Hot hits the ground. If my hot wire hits the ground wire, and I'm also bonded to my neutral bar over here, what's going to happen when hot hits ground is all that excessive current is going to travel on this equipment grounding conductor, and what it wants to do is facilitate the overcurrent device to open. So what ends up happening here is I'm going to have ground current come over here, and if I use the main bonding jumper here, I incidentally created a parallel path where I'm now putting fault current on the grounded circuit conductor. That could be dangerous because you could be feeding that fault current back on some other piece of equipment through the neutral, and you could be frying that piece of equipment. So let's get rid of that main bonding jumper for a second. And now look, if I have fault current coming on my equipment grounding conductor, I have a path of least, there's no resistance here because I'm connected completely all the way back to the source. So that current's going to flow unimpeded. It doesn't pick up a parallel path, and it allows this overcurrent device to open instantaneously. But on the other side, let's say I put the main bonding jumper in here. The other mistake that could happen is you can create what's called objectionable current. Objectionable current is found in the code book in Article 100. And what that is we accidentally will have ground current. And how can we get ground current? Well, if I have the grounded circuit conductor and the equipment grounding conductor bonded at a subpanel, anything that's connected to the neutral of this load or any other loads that are in that panel, well, that neutral wants to go all the way home. Wants to go all the way home. In the real world, this is isolated in the subpanel. So that neutral current has a nice clean path to pick up the neutral wire back to the service and have no issues. But if I go putting the main bonding jumper in here by accident, all of the branch circuit neutral conductors can incidentally also take this parallel path to ground. And what that does is it could accidentally put ground current on your normally not current carrying metal parts. If that happens, anything that you touch that might be metal, and if you touch a different potential, you pose a shock hazard on that surface because that ground current it now exists. So if you imagine you've got a 10 amp load plugged into this receptacle, well, we got 10 amps coming back on that neutral, and now all of a sudden these electrons see this path they can take. They're like, hey, you know what, let me see what's going on down here. This is low impedance. And all of a sudden you get a residual objectionable amount of current that's on that equipment grounding conductor. So not a good thing, because most of the times that equipment grounding conductor is bonded to other metal objects that could be in that building. Very often in a commercial building, a lot of our metal is bonded to framing steel and building steel. And you don't want objectionable current on that system coming from a sub panel. So There is a lot more to this than that, but the reason why I have this drawing up here is fundamentally we're always installing sub-panels in places. We have to understand that this panel is going to come with that green screw because they don't know if they're going to use it as service equipment. There's a sticker that comes in that box that says for service equipment only, and you put the sticker on the panel because it's service equipment. In this installation, the main bonding jumper shouldn't exist. So once again, I said everything we touch goes back to the code book. I'm going to zoom around and show you some code articles in here, but the important one that's in the code book is 250.32b1. Now when you read that, it's a language that's hard to understand, but basically they're saying, and I'll bring it up in the code book, is that this has to be isolated. These cannot touch. The other code article that says where they're supposed to touch is 250.24b. 250.102c1 shows us how to size that main bonding jumper. But there's more to it than this, and the important thing is you want to get it right. Main service, first form of service disconnect, main bonding jumper. Any panel that's off of that, away from this, becomes a sub-panel. Therefore, no main bonding jumper screw strap or any other means to connect the equipment grounding conductor to the grounded circuit conductor. We want to keep those paths isolated. Objectionable current's a real thing. Now, to go along with this, if you look at the illustration, let me get a better picture of it. I drew this 200 amp main panel with the assumption that it's coming in and your power is coming from the street. You know, maybe an overhead tap right there. And then this is kind of like two ungrounded circuit conductors on the secondary side of the transformer power from the street. Let's just say it's 120, 240. Once again, it is a multi-wire circuit, 210.4, so we got to make sure we're sharing that neutral, that we simultaneously disconnect both ungrounded circuit conductors with a 2-pole circuit breaker, which we do with the main. We're also doing it with the sub-panel. It is a multi-wire circuit. You're going to get a real good theoretic explanation of if you wire a multi-wire circuit wrong, you'll create a voltage drop. That'll come in a different video, and you could be blowing up TVs and compressors and whatnot because you'll have an over voltage on one circuit and under voltage on another. Here's my sub panel. It's just showing a representation of 2 hot conductors and a neutral tied in. And once again, we don't want the equipment grounding conductor and the grounded circuit conductor bonded. We want to isolate them. And I just drew what could happen if I had a faulty piece of equipment and how those electrons want to travel on an unimpeded, isolated path back to the source. So I'm going to leave this up probably for a few days. I'm going to have you guys copy this when you get into class. You could put this into your notes and hopefully remember this when we do our labs called electrical services, and this will come back again. And hopefully you enjoyed this, and we'll see you at the next video.